Great. I'm going to keep my camera off because my network is not so great today. But let's start with deep funding. So I would like to invite Devansh. Devansh, if you could give a quick overview of what is deep funding and just talk a little bit about the contest that just got launched, that would be great. And then we will go to David.
Yep. Thanks for kind of giving the chance to talk briefly. So we finally hit like a major milestone in getting a first data science competition uploaded, thanks in large part to OSO and Ivan and some of the others who could get the data in order, and Sejal as well. Like you really did a lot of work in that. Basically, we're looking at how we can have uh, AI being used for allocating funds. Right now, it's used a lot for like being a Twitter reply guy. Like I think that's what we are seeing all these agents become, which is like such a waste of talent, honestly. Like all these amazing agents and all they're doing is just trying to build Twitter followers and reply to people. So, but also on the other hand, we don't want to give too much power to the AI. So it's kind of this fine balance where we want AI to be a capital allocator, but we don't want them to be too powerful. So deep funding kind of is trying to strike a balance between both these extremes, where we have all of you taking part in these competitions and giving your own model, and we have some sort of jury mechanism to choose which is the winning model. So we also avoid, like, like in a lot of the controversies we've seen in government using AI for determining welfare benefits and other things, the biggest pitfall they did was building their own AI model, and then that had some discriminatory criteria, and like that really blew up in their face. So really deep funding is like a new way of trying to do that, where we have everyone building their own model. So that's why this is a primer, how to build your model. And we are working with like jury to actually give rankings to different dependencies, and we'll see which model is most closely aligning with those rankings. So we also give the word AI alignment a whole new twist with deep funding. So I won't talk more. I think there's a heavy agenda with David and Carl and even Open Rank coming and presenting. We've already had like 5 submissions, which is like really cool. Um, and David is like the coach for deep funding with Eval.Science, like trying to build up the capabilities of people who want to take part in the contest. So go ahead, David.
Thank you, everyone. Super excited for our Christmas primer special on Eval.Science. So just quick intro, everyone. If you're joining now, please keep your microphone muted, but feel free to turn on your camera and say hi. I'll turn it also on in a second. And also get involved and ask questions or share anything in the chat. So I think I want to just quickly ask you guys how your vibe is today. On a scale of cat, today, how are you feeling? You can just type in the numbers on the chat. So if you're like feeling like a 1, let me know. If you're feeling like a 2, let me know. Would be really nice. I'm not surprised that Marco's feeling like a 5. Nice. Super cool. 5. Many 5s here today. Thanks. Just turn on my video as well. So
5 is the Christmas vibe, I think. Yeah.
5 is the Christmas vibe. I think so too. It's just the holiday season. Yeah. Nice. Cool. So let's get started because we have today a really cool program prepared. Um, Devansh already talked a little bit about deep funding, so we can go through that very quickly. Then we're doing deep funding and friends today with a short tutorial of how you can create your first submission in 5 minutes. Then a tutorial on how you can use Open Source Observer to leverage and create new data sets and insights that also gets rewarded during the competition. So when you create a really cool new data set, that is something that the jury will also take into consideration. And even in Open Rank, we'll also talk a little bit more about how you can build your models. And always open for question answering. So what deep funding is, I think that Devansh has already explained it super, super well. But I really like to show this dependency graph on the right side that is from Deo Garques, one of the community members who's been contributing right now, leading the leaderboard in deep funding. This is all the dependencies of repositories to main repositories of Ethereum. And the goal is really to assign value allocations for each of these subdependencies. And that would be that is obviously a very difficult task to scale for human. So we would like to have an AI allocation for this. Deep Funding Mini, which we're now talking about, is right now running from the 24th of December until the 26th of January. So submission deadline on the 26th. And we are asking for 1,023 predictions where we provided a small data set of 3,410 comparisons between 245 repositories, which is a subset of this graph. That Carl can also talk a little bit more because he helped create this really beautiful data set. And then everyone's eligible for roughly 20K for open source model submissions, valuable data sets, and infrastructure that is useful for other participants. So this is really community driven, and we are really excited for us as a community to get together and tackle this really difficult and important problem. But now let's get quickly started on how you can create your first submission in Deep Funding. So for that, I'm gonna quickly show you a repository. So here at Eval.Science, not sure if you can see it, text me in the chat if not. We have this GitHub repository that we just put out called Deep Funding Mini that explains a little bit more on the background of the contest. You can click here on this Open and Collab Notebook button, and then it will guide you to this notebook. And Colab is basically, if you're not familiar with Jupyter Notebooks, IPython notebooks, it's like a data science Jupyter Notebook, so like a data science workbench that you can use while you're on the cloud. So it's not running on your computer, it's running on Google's machines, and all you need is just a Google account. And what you can then do is you can click on these cells, so it's a mix of text and code, and you can click on Run anyway to run this piece of code that will show you how you can download like a small prepared data set that we did for Deep Funding. So basically, this is a small data set that is inspired by the Deep Funding page and also inspired by Open Source Observer's dependency graph repository. And we just matched the two data sets, Project A and Project B, that you will need to do predictions from with a bunch of features that might be useful for you during the machine learning task. So features you can explore in the notebook. But really what you should be focusing on here are the weights of A and B, which is considered to be ground truth labels here. And the weights determine roughly how much funding this respective repository has received compared to the other one. And we want you to kind of figure out a machine learning model that you can train on top of this and predict for 1,000 new comparisons where we don't provide the weights, what are the true weights. How you can do this is, for example, this is how you access the training data set. And then you can switch around between train and test by changing this. And then one thing we can do really quickly is, so this is called a pandas data frame. We can just create 4 simple baselines. We can see, okay, what happens if all the predictions are just random? So like 50%, 0.5. So that's the first baseline. The other one is, what happens if you just take the metadata of star ratios? What happens if we just take the metadata of like fork ratios? And what happens, of course, if we take the total funding data? And then we can run this. And the competition is running and evaluating according to a mean squared error. So we can kind of predict this on top of the training data. And then you can see the scores where random is actually providing quite a very solid baseline, even better than the stars and the forks. Of course, not better than the funding, because the funding is where most of the proxy data has been derived from the signal. And then if you have that and you decide on a prediction, all you need to do is load the test data here. With this function, calculate, for example, we want to just submit the GitHub star ratio. So we can run this and then have the funding submission document be written. And then you can find the submission document actually here on the left. So it was like saved now here. And there it is. And you can just download this here. Let me quickly download this for you guys. And all you need to do is go to the deep funding page now, linked here, create a Hugging Face account. So we're running the competition on Hugging Face, which is machine learning, is basically open source home. It's like GitHub for machine learning. And then you can just upload the CSV here with a short description what this is. And ta-da, you have your first submission and you can check it out on the leaderboard. So hopefully this helps you get started really quickly on deep funding at the mini contest. And we're really excited for your submissions because the more submissions the community is giving out, the better our models get, the better the conversations are getting, and the more important, we will figure out how to run the big competition. So thank you so much.
To recharge and restore for 2025. But for those of you who are, I hope you've been having a good break. And for those of you who are grinding through the holidays, hats off. I'm really excited to see what you come up with. We actually didn't coordinate any of this, and I think it's really it's amazing that David gave an excellent example of how to get started with the model. I'm going to give some examples of how to get more data. So if you want to add new features to a model, because obviously the example that David showed was only using a limited set of features as a proof of concept. I'm going to show some examples of where you can get more features if you want. And then I'm really excited to hear from Gloria and the team at OpenRank as well, because they are going to show how to run algorithms against like the entire contributor graph or to do some additional cool things. I actually don't know what they're going to present. I'm just guessing that they're going to show how to create a PageRank run a PageRank like algorithm over the graph, which is super, super cool. And I'm also glad that this is being recorded because people who aren't here will be able to take advantage of these tutorials. So what I've done here is created let me just double check. Can everybody see my screen? Are we good?
Yep.
Excellent. So I've shared another notebook, which basically gives people an overview of how to do some pretty basic things with the data sets that Open Source Observer is maintaining. And a little bit of background is that what we've tried to do is leverage public data sets that already exist wherever possible. So as many of you know, GitHub data, any kind of commit activity or any activity which is associated with a public repository is public. You could, if you wanted to, create your own scraper to index all of that data. There's a valuable data set called GHArchive, which has already done that work. And so we have taken advantage of that data set. There's another data set called deps.dev, which is maintained by Google, and that looks at the entire software supply chain and creates a really, really big dependency tree. We've also tried to connect the GHArchive data with deps.dev so that you can now view, like we have for this, for deep funding, the a good amount of the software supply chain. There are other data sets that exist. We've looked at funding data from sources like Gitcoin and Open Collective. There's kind of other grant programs which have created entities like projects, and you can link different things that those projects own. And so we've tried to curate all these different public data sets and put them in one place, a very large data lake, so that you can spend as little time as possible doing data engineering and indexing, and hopefully as much time as possible testing your model, building it, and trying to improve it. So again, here's an example of how to take advantage of some of these data sets. The reason that all of them are hosted on BigQuery is because BigQuery makes it very, very easy for people to get started and find a public data set. And they have a pretty generous free allowance for people to, use credits, scan the data without needing to pay for anything. I think it's like 1 terabyte or 2 terabytes per month, which my guess is going to be enough for most people to do this data competition. That's great. The other benefit, of course, is that you have tools like Colab, which make it very easy to share notebooks, and you can even hook them up to AI models. So again, the objective of this tutorial is to show 5 different use cases that can be powered by data which is already available on Open Source Observer. And so the first example, actually, the first thing that this will include is a kind of a quick start for how to get access to the data if you haven't done it already. So the first step is actually just to go to OSO's docs, and there's a link here which will help you access the public data sets. And what you need to do is click this button to subscribe on BigQuery. So we're going to click this, and it will take us to a page where you can click this button, And I've already done this, but it would allow you to come in and give your link data set a name. Now, I've already copied this one, so I'm not going to be able to save it because it already exists. But in any case, that is how you subscribe to a data set. And then you should be able to go into your own BigQuery SQL console and start querying the data. So if you want, you can see all of the different you can go in and there's a whole maybe 200 plus tables that exist here. The ones that have a version number are the ones that we feel confident exposing to the community because they are more or less stable. Ones that don't have a version number, they could be further up the supply chain. So we wouldn't recommend using them, even though you will be able to see them because they're part of the OSO production schema. So in any case, this is an example just to see if things are working. Another useful tip if you're new to BigQuery is that every time you prepare a query, it will give you a preview of how much it's going to cost to run the query. And again, I think Google gives you about 1 terabyte of scans free per month. And so you should be able to do pretty much everything you need while staying well under that limit. So again, here's just an example to make sure this works. You can execute it, and we get an example of some projects and their names, display names, etc., back from the database. So we're working. So this quick start gives you an example of how to do that. One of the first things that people will want to do, and David's example shows one application of this, is look up some basic stats about a GitHub repository. So here, maybe we want to find out what language is it in, when was the last time it was updated, what license does it have, how many stars, how many forks, etc. And so we have a model here, which is called repositories v0, where you can put in an artifact URL. So this is basically the link to its the GitHub repo, and then you can see basic statistics about that repo. Now, this is all the same type of stuff that you could get by pinging the GitHub API anyway. The benefit of having it here is that you don't have to do that. And so you don't need to write any code. You can just access the index data. And GitHub has pretty strict rate limits because obviously there's a lot of people that like pinging the GitHub API. So you'd quickly get rate limited. So we have done this for a large number of repos, not every repo in the universe, but there's a large number of the ones that are in the data challenge are included here. And you can access all of them by querying this query over here. I can give a quick example of that. Let me just pull it up here. So you can run this one here. You could change it to any other URL if you wanted to. And this is a pretty cheap scan. It's only about 28 megabytes. And we'll just run it here. And lo and behold, we get back what we'd expect, which is the Go Ethereum repo. You can see the JSON format as well. And here's, again, some basic information that you would be able to get in the same way as if you were to click the link over here and just get these things from the side pane over there. Nothing fancy, but it's a good starting point. Another thing that you can do, which is kind of a second use case, is maybe you want to look up all of the repositories that have the same owner. Now, in OSO language, we call the owner of a GitHub repo the artifact namespace. And the reason we call it that is because we have different types of artifacts that we're looking at. It could be a GitHub one, it could be a package, it could be blockchain related ones, etc. And so we wanted a common language for indexing all of their events. And so yeah, we've called basically the owner the namespace. And then if you just wanted to get the name of the repo, that would be the artifact name. But in any case, here's an example where we can grab all of the repos that are owned by libp2p. That's a popular repo that you'll see in the deep funding graph. And so we can get the same data back. And here there's more than 200 repos that are owned and maintained by libp2p. If you were to run that yourself, it would probably take, I don't know, half an hour or so to get all the data back. And here we have it ready to go for you. So you can see that as an example. And yeah, I think that's basically it for the repositories v0 data set. Let me just see, are there any questions that have come in, Sejal, that I should address before going forward?
Yeah, there are. So Sadiq is asking, is it possible to filter queries for only Web3 repos?
There isn't like a single field that I could give you right now that would allow you to do that. What we do have, I haven't showed it here, but we have a table which is basically well, I'll do a quick demo here. So if we were to do, we have this table called projects, or we can even do, yeah, I'll just do products by collection. And we could search where collection name, I forget the name of it, but I'm going to do a like command, and I'll just put Ethereum, sorry. So this is very basic, but I think we will be able to get a more filtered set of projects this way. And so these would be ones that have been tagged by someone as being part of something that is Ethereum adjacent. If you wanted to, you could also look at, I think, Optimism. We have a number of these things labeled here. And so this would give you probably a more curated set of repos that are more crypto focused, but there isn't a guarantee that they are, they could have been just like a grant recipient from Gitcoin or something, and they could still show up here. The other thing that we can do is some products will have deployers or other addresses that are kind of included as artifacts. And so you could filter on projects that only have some kind of blockchain artifact in their page. Happy to also chat more about that offline if that's important to you.
Great. So next is Tendon Par is asking, does the dataset update nightly?
No, it updates weekly on a cron. We can run the indexer more frequently. It's scanning a lot, and we haven't really optimized things for being able to just scan a subset of the data. So right now, we try to limit the number of runs that we do to just once a week automatically. But if there's like a major change or thing that you need, then we can definitely, trigger a job for you. I'll give an example at the end which kind of shows how all of the data works. The entire pipeline is open, so you can see what's running at any given time and when the last indexing job completed. But right now it's scheduled for every Sunday night.
Nice. Wonder is asking, are there ways to generate more granular details for individual GitHub events, like timestamps for?
Yes, let me show you that at the end. I guess that's my prompt to continue, and we can take a few more questions later on because I want to be conscious of time. But yes, you'll be able to do that, and Gloria will give some good examples of where you can go from there. Okay, so the next example is if you want to identify the larger project or team behind a repo. Again, we've given an ID for all of these different artifacts, so you can grab one of these artifact IDs over here that came back from this type of query, and then you can go back in and look up, say, who the owner of that project is. So in this case, I took an artifact ID from libp2p. It gave me the product name, libp2p. I can go back in the other direction now. I can say, okay, give me all the things that are owned by libp2p, and it will give you many more things. So we have all of their repos, we have npm packages. If they had deployers or other blockchain artifacts, we'd get those too. So that's a good example of how you can start tagging projects or teams based on the types of work that they're doing. Okay, now we're going to start getting into what I would say is some of the more interesting stuff. The graph that we shared was created by looking at a data set that GitHub maintains called the Software Bill of Materials. And this is basically a way of kind of capturing everything that is in like the package files for a given repo and the things that might be upstream of that. So if this is npm, you have direct dependencies, and then you have indirect dependencies, which represent the dependencies of your dependencies. And for software teams, it's very important to have a good understanding of where there are updates that are happening in your dependency set. And in some cases, they could introduce vulnerabilities or bugs. So that's why GitHub maintains and open sources this data set. But obviously, we can use it here to get a sense for who depends on who else, and use that to create our graph, which is the heart of this challenge. So here's an example where we can look up, again, here's a software bill of material. I took the from artifact ID here is, which one? I think that was Go Ethereum, right? Just double check it. Yeah, so Go Ethereum begins with 0M. If I come down here, yeah, okay, so this is the Go Ethereum. This is their repo, so anything that Go Ethereum depends on will come up in this query. And so you can see that they have a lot of different dependencies. In total, there are more than 140. Go Ethereum is obviously a Go repository, and so you can see all the different packages that they depend on here. We can also look things up in the other direction. So we can see, we can take a particular repo, or sorry, we can take a particular package. And so, and we can identify, sorry, what is this example showing? So this is taking, this is actually looking at something slightly different. So it's saying, here's a given repo. What are all of the, what are all of the NPM dependencies here? So it's just another example, this time looking at libp2p, taking one of their repos and seeing all of the packages that it depends on. The next thing we can do is kind of look up the maintainer of a package. So here we're kind of combining two different data sets. There's the software bill of materials one that we just showed, and then deps.dev, which basically looks at the entire software supply chain and tracks when different dependencies were added or removed. And so here we can take an example of a package here, this one libp2p echo. So I'm going to look that one up, and I'm going to identify who is the owner of that package. We already know the answer to this, but if you didn't know who the maintainer of that package was, you could find it out this way. And so it takes us back to libp2p, and the name of the repo is the JS libp2p repo. Okay, great. Pretty obvious, but we found that out. Another thing that we can see here is that this repo, which has the ID that I copied in over here, is also maintaining a whole bunch of other packages. So there are more than 60 packages that are maintained and can be traced back to this particular GitHub repo. So that could be an interesting feature that you want to look at, how many packages trace back to the same repo. Now, I think this is a wondrous question. How do we do things at the contributor level, kind of go within a repo and identify all of the events that might be happening to it and who was the contributor? This is a great use case. The team at OpenRank has definitely taken advantage of this data set before, and hopefully we'll show some examples here. But one thing I will warn you about is that this is actually a very large data set. If I want to scan it, I think I have an example here. So if I go in to scan this, I'm requesting probably more than 100 gigabytes of resources here. So it's expensive. Do this sparingly. I might recommend keeping like a local copy, either in your own BigQuery instance or as like a Parquet file or something, because this can get expensive if you're scanning it regularly. But in any case, what we're doing here is identifying anyone who has committed code to, this is the Go Ethereum artifact ID. So what this request will give us is basically the handles, the GitHub usernames of anyone who has made a commit to the Go Ethereum repo. And this goes back, I think, to 2015. So it's a pretty comprehensive data set. Again, this would be very expensive if you wanted to index it on your own. It would take a long time just for one repo. So it's nice that this is already ready for you. And you can see here that there's only been 17 contributors over time. And obviously there's a power law function. So, Carlabe, FJL, they've done a very large share of the actual, commit activity to this particular repo. Now, the other thing that we can do, which is kind of fun, is we can take this username. I think we use, so we use Carlabe, the first one, and we see, okay, well, what else has that person done in the ecosystem? So we can take them as the from artifact ID. We can look at any type of event that they've done on any other repo that's included in the data set and see what we get back here. So there's been a lot of interest in this project maintained by Off-Chain Labs. Obviously, a lot of other kind of Ethereum-related activities, opening issues. You can see what they've starred. You can see if they've reviewed pull requests, etc. So this is kind of a great additional exploration space for people to identify, okay, who might be some of the most trusted contributors in this dependency graph, identify what other things have they done over time, and hopefully create some new features from there. That's it. If you want to see more examples of working with this data, we have included a few notebooks in here, which kind of have the same structure. And you can come in and see how they, go in and request different data. Here in this case, you could copy this into your BigQuery and run it and download it locally, or kind of do it in your Jupyter environment. The other thing that we have here are some additional documentation if you want guides or a bit more explanation of what the schemas do. Those are all contained here in the docs. And finally, if you want to understand where any of this data is coming from, the entire pipeline is also open, so you can see all the different sources of data over here. And then you can take a particular model and trace the lineage of it. So here's like the really big one, which has all of the events kind of broken down by the artifact. And we can kind of go back and see all the different tables that feed into that one and the ones that feed into those, and all the way up. Here's where it starts to look like spaghetti. So you can kind of see the entire tree. And again, this is the part that required a lot of engineering effort, and hopefully anybody from the community is able to hit the ground running by just taking advantage of these version models, which have hopefully, made life easier for you. But again, if you run into any issues or have questions, please reach out over Discord or over Telegram. And once the holidays are over, we will be as prompt as possible to respond to any questions or ideas that you have.
Wow. This is so cool, Carl. Thank you for sharing. Just one question maybe we can take where Lara is asking, what is the difference between OSO project ID and the project's GitHub URL? What does this ID refer to? Can it include projects from several GitHub URLs?
Yeah, so one of the challenges with the GitHub URL is that over time, people might change the name of the repo, or if you are a GitHub user, you might change your name over time. And so if you look up a URL on GitHub, it will actually give you back a node ID. And so that's their own way of kind of tracking who the owner of a repo is, or what like the actual ID is for that repo, because the URL might change over time. So we've also kind of used that as well. And when we create our ID, all we're doing is basically hashing together, I think, the source, the ID that is used by that source. So in the case of GitHub, it's, that would be the source, and their own repo ID would be the, their unique source ID. We hash that together to come up with our own artifact ID. So it is deterministic. And that we use that same logic for NPM packages, for blockchain artifacts, for Twitter handles, for anything.
Great. Thanks so much, Carl, for your time. And for those who don't know, I just want to say huge thanks to Carl and team at OSO. I think data is such a critical part of this whole pilot, and it would have been impossible to really, start with this without the work that you guys have done. And the responsiveness that you have, it was so fast. Devansh and I literally were talking that we were feeling so much energy and everything to go forward, because by seeing you and, the speed at which you've been working. So yeah, thanks for everything.
One thing I will say, thank you very much for that. We've been incredibly fortunate to build off of other public data sets that exist in the space. And there's a huge amount of work that has gone into creating those data sets and maintaining them over time. And so we obviously want to pay that forward. And I think one of the great goals of this experiment is that we can encourage other people and hopefully create incentives for them to generate public data sets and create models that allow you to connect and compose with those data sets. This is such a great application of that, and it took probably a year of work to get to the point where it was actually very easy to spin this up in a couple hours. So we were really thrilled to have a great use case to put this data to the test.
Yep, and now you can also pay your own dependencies, this full.
Exactly.
One person I want to give a shout out to is Ivan, who actually worked with a lot of the data to get the challenge up and running. So Ivan, we are over time, but if you can just quickly talk a little bit about how you did the data and how you did the challenge and what people have to give.
Well, first, Merry Christmas to everyone. I think that almost everything has been said in the conversation. I said to you, no, the thing is I've been supporting Seychelles and Devansh on creating the contest. Maybe the only 2 points that I would love to share with you is that you try to push in the community space of the contest in HuggingFace, in the space of HuggingFace, that you can share all the notebooks, the tutorials. The thing is not, the goal of this contest is not only to submit, yes, you want to win the prize, but also to start to trigger the conversation. No? So the good thing of HuggingFace is that there is a space where you can share resources. I think that maybe the jury and also want to reward people that can create content, infra, so others can build the notebooks and the models. No, so this is one point. Share as much as you want and as you can, and also maybe to share some here in the chat some resources from HuggingFace and Kaggle, where you can learn how to create notebooks, how to submit models. No, so I will share it in the chat. Here first the HuggingFace one, okay, and then the Kaggle also. I think it's that the kind of side. Let me check. Yeah. I think maybe the two more important points from my side. No, start the conversation and learn as much as you can. And all about that, I think that all about sharing with Cal, I've been very, very precise. You have the repo where you can deep dive a lot on the data. And from there, good luck on submitting models. No?
Amazing. Yeah, and just want to say, like, feel free to reach out to Ivan directly or just message in the group in case you have any questions. Devansh, you want to introduce the Open Rank team and then we can move.
Yeah, so I knew some of the Open Rank team members before they were there, and when I heard of them, like they reached out through one of their team members, and I'm like, wow, this is like super relevant for model builders to incorporate metrics into building their model. And I think what I was especially fascinated by was the fact that they've already done this before. They've done a ranking of repos for Optimism's round. So I said, like, you guys have to come onto this Eval.Science call and kind of just run other model builders through the process. So I'll give it over to you, Gloria, to quickly run people through how they can leverage Open Ranks models.
Thank you so much, Devansh. And yeah, it's actually really great to see many friends in the call. We collaborated a lot with OSO, with Carl on different optimism projects. Basically, we used different OSO data and generated reputation ranking and scoring for different purposes. So one of the one that is quite relevant for this competition, as Devansh was mentioning, is what we did for optimism, basically ranking all the contribution of repos and developers to the core OP stack repository, and then kind of like build like a reputation contribution graph from there. Let me maybe share my screen just to give some context. And these two links I sent in the chat. So they are basically what I will be sharing in this call, and you guys can see my screen?
Yep, we can.
Okay, great. Yeah, so let's start with introducing a little bit about OpenRank. So we are a decentralized ranking and reputation protocol. So this protocol enables a verifiable reputation compute layer for the open web. And there's a lot of graph compute algorithms we're using, such as eigentrust, and it offers like resilience from symbol context, and also provide very context specific and scalable compute for the reputation data for different use cases in the web. And just like help to understand where do we position in the tech stack is that we, for example, we take data from open source observer BigQuery, and then we'll apply our algorithms, compute on top of that, and we'll be able to generate computational results. But we don't really do model ourselves. So we provide this graph algorithm compute infrastructure. So any particular teams or developers or projects or front end, they can bring their data. They can use the existing data we have hooked up through our ecosystem partnering with OSO, and you can tweak the inputs, and you can basically use different kind of weights and parameters and generate reputation scores and rankings based on your particular context. So we have encapsulated this capability into the OpenRank SDK. So this is the complete documentation of OpenRank SDK. You can basically use it and generate your own reputation scores and having your own tailored insights and taste into how you apply our set of algorithms there. And for the case study, we did a front end. I think you should be able to see this, right? We did a front end to give like a more easier illustration of how does this OpenRank SDK work. So say that you're trying to create developer rankings for different contributors of GitHub repos. We define in this graph basically two kinds of nodes. So one kind of node is the GitHub repos. The other kinds of nodes are basically users, developers who have contributed to the node. And we capture two kinds of signals, and they form the edges of this graph. So one type of edge is the user to repository to trust. So signals the user basically do is like starts, forks, or issue a PR, submit a PR. And the ripple to user trust, which is the other direction of the signal, is basically the credit extended by the repository to the user for their contributions. So such actions include like PRs merged, direct code commits received, and other maintenance actions. So for the ones who are not super familiar with PageRank, eigentrust, this foundational method is basically trying to capture the web of trust via a recursive trust algorithm. So in this case, given like a community of peers, their interactions with each other will directly form a graph, and these peers will become the node within the graph. And the eigentrust algorithm can then run on each graph to measure the impact of the recursive trust propagation, leading to a global trust value for each peer or node in the network. So at the end of the compute, every node gets assigned a reputation score that is global. In this particular case with developer rankings, it is a bar parity graph. But we're still going to be able to use a variation of eigentrust, which is Hobson's authority algorithm, to basically recursively rank the relative trust of each node in the graph. So you could understand it as we capture the micro interactions between user to repos and register them as how much they trust the others, how much they depend on the others, and then recursively harnessing that insight, and then eventually everybody gets assigned a relative score in that graph. So this is an interactive front end that uses our SDK and open source observers GitHub data. So you can already kind of play around with it. And if you click on this link here, that gives you a more comprehensive explanation of like how this algorithm was designed and work for this particular use case. I will not go into those details, but leave more time for questions since we have limited time. So once you understand this part, this is basically how the trust graph was formed. then you can choose seed trust. So basically, seed trust, in this case, we use a couple of ripples as the initial seed peers of this graph. So in this example, we used basically, these are all like core ripples for optimism as a project. You can easily replace these with core ripples of Ethereum and assign them like how core are they to the development of the Ethereum with a certain weight. And then you can also set like a seed strength. For example, the stronger the seed strength, like let's say 1, between 0 and 1, you choose almost like 0.9 or close to 1. That is a parameter that determines the influence of the seed peer's opinion in ranking all these other peers in the graph. And you can play around with it and see which strands that actually make more sense in your ranking approach, and then compute results. This is basically done on the client side on your computer, so it will take like about 15-20 minutes. And then you can download the CSV as like a example. So the bigger the data set is, the longer it will take, but this could be a good interactive way for everybody to understand how this compute works. I'm gonna pause here and see if there's any questions. And also, Eugene is also from our team, and he's actually the engineer who basically did this whole thing. If you have anything you want to add to explaining OpenRank and how developer can use it for their own reputation rankings of GitHub repos.
Like not too much on top of like what you already covered. I guess we can actually start with questions. I already see that Sidek actually posted one. Can't devs game the algorithm, albeit to a limited extent, using stars and commit factories? So yes, that is actually why we use actions back to users, not based upon the actions or like. So yes, in the graph that you see between user and repo, from the user to repo signal, like user trusting repo or user extending trust and propagating some of the trust budgets that he received back into repo is based upon his own actions. However, if you see the trust token number 2 at the bottom part, actions such as peers merged, direct code commits received, and other maintenance. These things are actually not possible by the users themselves. For example, I can only I can open like hundreds of PRs against the repo to simple attack it, but in order for that to actually count, one of the maintainers of the repo will have to approve and merge that PR. So it's not a unilateral action from my side as a Sybil. In order for this to make sense, someone on the side of the repository basically encapsulating and representing the well-being and good intent of the repository as a collective will have to recognize my action as noteworthy, or like in other words, my actions as a valid contribution. So this is basically how this scheme, we actually called this interest and credit scheme because of that. This actually subverts a lot of civil actions on its own. Does that answer your question, Siddiq? Awesome, thank you. Any other questions?
Do you want to show a Python SDK for people? Because it might be useful for them to.
Yeah, I can. If you have a group chat, that we can probably post the material like after the meeting. Right now I'm actually on a really limited connection, so I cannot share anything. I'm in the mountains.
there's a group chat going on with like 400, 500 people in it.
Yeah.
We can definitely share the Python SDK.
Yeah.
Yeah. All right. Devansh, do you have any questions? Or
Yeah, I guess
David?
like the most clear question is like how we can apply it to the relevant repos that we are considering. And yeah, which is around 4,303 repos in the main contest. And in the mini contest, I think there's around 245 repos. So what would be the easiest way for model builders to incorporate some of the infrastructure that you've built?
Yeah, definitely. You can directly use the OpenRank SDK that we were talking about to basically run with larger data sets. This create your own rankings. This front end is just for like demonstrating how the logic of the compute is, rather than actually doing a model for this context. Because you can now put more than 50 repos in that chat box, right? But you can definitely do with the SDK with more repos. Yeah. Thanks, Carl. Yeah, Carl just sent that link in the group chat.
But like one quick follow-up. So if you're doing rankings of repos, you won't get weights between them, right? You'll just get this is number one, this is number two, this is number three. But what we've asked in the mini contest and also the main one is to give weights, saying that this is maybe 0.7, that is 0.3. These other two repos, one is 0.6 and another 0.4. So is it more relevant to rankings or can it also be used for weights?
Yush, do you want to answer that question first?
Yes. So this like delves into like a little more details into how this algorithm eigentrust works. Unlike a vanilla PageRank, which is unbiased by default, everyone gets the equal footing by default. Eigentrust actually introduces the concept of seed peers. Gloria covered this seed peer concept a while ago. Basically, seed peer acts as the source of trust into the system, meaning that even if no one else vouches for these repos actions, for example, we have how many like 8 or 10 different seed repositories. Even if anyone else actually are interested in these seed repositories, and there's like no incoming trust arc into these repos, any actions taken by the seed repos will still have voice. Basically, eigentrust is based just like PageRank, is based upon simple formula. Whatever opinion I have and I express about others contributes only as much trust I actually receive from others. This is basically a loop, and in order to break the cycle, or in order to inject the initial trust, which actually defines the flavor or the kind of trust that this score is trying to achieve, we basically select these seed repos so that we can assign that like even without any other actions for these repos. These repos still get a certain amount of voice. That amount is now determined by two factors. One is the relative distribution of seed repos. In our UI that Gloria demonstrated, you'll see that some repos only receive 0.5 or 50%, and the other repos get by default 100%. So there's like a 1 to 1 to 1 to like 0.5 to 1 to 1, that kind of like ratio. And there's also the overall amount or strength of seed repositories opinions, and that's what Gloria explained as the alpha value. So yeah. Basically, you can understand these weights that each repo can be associated with as the budget or the share of the budget, trust budget, whose absolute amount is determined by alpha, 0.5.
Thanks for all of you
Yeah,
presenting. And I think as David mentioned that we should try to prepare this as a dataset commons for everyone. So really cool to see how Open Rank gets used in the mini contest and the main contest.
great. Yeah, thanks very much. If anyone has any questions, yeah, we can follow up in a group chat. As Carl mentioned, we'll be also more responsive after the holidays.
Thanks to everyone who came from the holidays and from the mountains and from wherever to actually come and be part of this session. Like really appreciate the extra hours.